Welcome to Web Handling. My name is Dave Royson. I am super excited to continue our new series called War Stories. In this week's show, I am taught by my mentor how to check my own work. While this specific story is about finite element modeling, the lesson is much larger. I know your time is precious, so let's get started. Recall that a war story is a memorable personal experience that we might learn from. We are guided by the saying that a smart person learns from their own mistakes, but the wise person learns from the mistakes of others. In this engineering story, we might learn, yet again, not to trust computers. However, that is overstated. Computers almost never make mistakes. It is the human that chooses or designs the model, applies the inputs, and finally interprets or applies the outputs. Ultimately, it is almost always operator error. As with most engineers, I've been a modeler for years. It started with one-line solvable equations that we might have learned in school and then maybe applied at work. Some of us went farther. I was a finite element modeler for years doing machine design work. This is the subject of this war story. Later, I built custom winding models for my PhD work at the Web Handling Research Center at Oklahoma State University. $1 million mistakes are not unheard of with machine builders of a certain stature. To reduce those errors at Beloit, we all underwent informal apprenticeships. For example, I literally helped carry the bags and fetch supplies for senior service engineers who were a bit frail. Our designs were always checked and cross-checked by at least 2 or 3 others. But for the first couple of years, there was an additional layer of apprenticeship applied to these other routine checks. Some of us went further into specialties. 2 that I learned were finite element modeling, the subject of this story, as well as FFT vibration analysis, both of which I learned under a brief apprenticeship. I only had 2 lessons with a senior computer specialist and finite element modeler, but that was enough to ensure that I got started with the right mindset. The first assignment was to find the stresses and deflections of a person sitting on the edge of a table. Something like the picture here of me sitting on the edge of the credenza in my living room. I was quite eager to do things right, so I asked, what is the size of the table and the legs? And how much does the person weigh? And where is she sitting? My mentor replied, just make something up reasonable. Now I imagine he was thinking to himself, kid, don't waste both of our times. Show some initiative and imagination. A couple of days later, I returned to my mentor for a follow-up, and I said, I finished the model. Here are the stresses and deflections. He replied, how do you know that model is correct? And I told him, I double-checked the inputs. To which my mentor replied, not nearly good enough, son. He told me I should have also checked the outputs as well. As just one for example, the vertical reactions on all 4 legs should sum to the combined weight of the table and the person. All I could reply was an embarrassed, oh. Then came the real lesson about the real world. My mentor asked, how did you model the attachment of the legs to the table? I replied, well, fixed in 6 degrees of freedom, of course. To which my mentor replied gently, though he might as well have shouted, he said, no, my friend, our extensive studies indicate the best bolt joints are but midway between perfectly fixed and a perfect ball joint. He did not need to say that what we're both thinking is I had better list and examine my assumptions much more closely in the future. That was the best and perhaps the only lesson I needed from my mentor. Not only are design mistakes expensive in the paper machine world, so are modeling mistakes. It takes the better part of a year to learn the craft. Also, the hardware and the software to do such are very, very expensive. That means that you must do due diligence, as they say. As you should suspect, this story is not about finite element models or even equations per se. It is that the real world is far messier than you think. So you had better think harder about what assumptions you are making, how they can be checked, and how modeling errors might affect the results. I hope you've enjoyed this model tale. Stay tuned for next week's show, where I will share how people may not hear bad news, even when it's in stereo. If you have a topic you would like to hear about, let me know in the comment section below. If you found any of these stories to be interesting or useful, please like and share and subscribe. See you next time.